Theory and Practice of Silviculture, lecture number 14. In this series, we are going to study about the silviculture system. In my previous lecture, we have finished about the clear felling system, and under the shelterwood system, finished about the uniform system. We have discussed completely about the uniform system. In this lecture, we are going to discuss about the group system. So, as already we are familiar about the classification under the high forest system, where system of concentrated regeneration, we know that we have two subparts. One is called the clear felling system and other one is called the shelterwood system. In the system of concentrated regeneration, clear felling system, we have discussed about the clear felling system, clear strip system and the alternative system, strip system. In the system of concentrated regeneration, another one is called the shelterwood system. We have studied about the shelterwood uniform system. In this lecture, we are going to study about the group system. Then in the coming lectures, we will study about the shelterwood strip system, Wagner's blender Samslock, Eberhard wedge system, strip and group system. And this we have two uneven edge. The one is called the irregular shelterwood system. Another one is called the Indian irregular shelterwood system. Under the again uneven edge system, that is called the system of diffuse regeneration, we have two systems. One is called selection system and the group selection system, and the last one is accessory system. We have three under this accessory system. One is called the two-storied high forest system, high forest with reserve system, and improvement felling. So this lecture we are going to study about the group system. Now, what is group system? This was developed by Karl Gehr in Bavaria in Germany against the increasing popularity of clear felling system in Germany. So it is generally known as Gehr's or the Bavarian Fammelslag. This system is also known as Bavarian Fammelslag, the group system. So this is the entire forest here. We can see this is the green color. I have made some red colors here dotted here. It shows some of the advanced growth which is coming here, advanced growth which is coming somewhere in the forest, just to make you understand this what is the group system. So these are some advanced growth we can view from the top view. In which group system, in which regeneration felling, instead of being done uniformly, as we have discussed in uniform shelterwood system. So regeneration felling, seeding felling, secondary felling, final felling, which is done instead of doing uniformly all over the compartment. How we do? It is carried out in scattered groups. So it is carried out in scattered. So you can see some advanced growth are scattered here. So let's go for back again with the definition. In which the regeneration felling, instead of being done uniformly all over the compartment, are carried out in scattered groups, either because of presence of advanced growth in those groups, some advanced group, either there are some advanced group, or to induce regeneration, or we induce regeneration. This foci of regeneration can be enlarged, centrifugally will enlarge, and they will merge with each other. But how we will do this one? Again, I want to go to the definition, because if we understand definition, we can understand the system very nicely. In which regeneration felling, instead of being done uniformly all over the compartment, are carried in scattered groups. They are carried in scattered groups, either because of the presence of the advanced growth here, or we induce the regeneration artificially in this foci. So they will enlarge slowly, centrifugally, and merge with each other. Now, for example, here was advanced growth. Here we started doing seeding felling here, and here also one point we have started doing seeding felling there. Here there was no advanced growth, or we have induced by felling one or two trees, so regeneration has come up. So this way slowly we will enlarge centrifugally and merge with each other and finish the regeneration felling. Now how we will do it? So let's take an example. Thus, regeneration of the compartment does not take place uniformly all over the area. The condition is like this, the species is like this, that the regeneration doesn't come uniformly all over the compartment as uniform system. So this is the difficulty in that area or in that species. So, but starts from some natural nuclei or group of advanced group. So we see here some group of advanced growth coming here, some advanced growth coming here, or from artificially created nuclei, or we created artificially some here, okay, and spread centrifugally. Slowly regeneration will keep on coming here centrifugally like this, okay. They will enlarge it, and as the regeneration comes, we will do seeding felling, secondary felling and final felling. So before starting the regeneration felling, it is necessary in group system, before starting the regeneration felling, doing seeding felling, secondary felling, final felling, it is necessary to go over the compartment. Now we have to go in the entire compartment. First we have to go in the entire, this is the entire compartment, and then we have to go in the entire compartment and locate the group of promising advanced growth here. We'll locate where here we are locating here. It is not an easy job. Well, no doubt remote sensing also helped to do nowadays this one. Early days it was very difficult. Then after locating the advanced growth, in order to enable them to spread centrifugally, seeding felling is done in periphery around them. So we have seen this advanced growth here. For example, we have seen this advanced growth here. So this advanced growth we have located somewhere here. This advanced growth we have located somewhere here. Okay. Then what we'll do? Seeding felling will do. This area advanced growth we have located in that forest. Here we will try to do. We know that this advanced growth is coming. This site will go for regeneration, and we can go for seeding felling on the periphery of this area. So this is for advanced growth, and if these groups of advanced growth are not adequate, we are not finding adequate other way. Suppose let's go to this forest. Here we are getting advanced growth, here we are getting advanced growth, in this side we are not getting advanced growth. So what we will do, some gaps are created by felling trees in small groups, enable regeneration to come in this gap. So we will fell this tree here and there, so that we admit some light and wait for the regeneration to come. As the regeneration come, here also we'll start doing the seeding felling, secondary felling, final felling. So seeding felling is done there as well as in the natural foci. So here seeding felling we have to start, because what is happening here we have find this artificial felling we have done here, and this is the natural advanced growth we are coming here. So in this area we'll go and do seeding felling. So this is the first step, doing seeding felling in the periphery. When we do seeding felling in the periphery, we have seen that now growth is coming enough, lot of other seeding also coming nearby that area, so we can go up for secondary felling in this gap. Now this is the mark of seeding felling. You can see as the seeding felling is completed here in this first ring, so we'll go in the periphery and do seeding felling in this group here. We'll do seeding felling here, we'll do seeding felling here, and then the group which we have done seeding felling earlier will go here on secondary felling. Okay, let's understand back. This is the seeding felling. When seeding felling we have achieved here, and seedlings are coming up well nicely and they are growing up into sapling, so we will increase or centrifugally go enlarge that area and do what we have to do here. We'll do here outer ring, again we'll do seeding felling. The inner one where seeding felling we have done earlier, we'll go for secondary felling. So now the thing is like this, that why we do group system here? This is actually practiced in European countries, in the northern hemisphere, this area, because we see this is the equator, sun is here. Here the insolation is coming, the light is coming with a very oblique here, like this it is going. It is not overhead as it is in our country in India. It is in the European countries, this area in northern hemisphere. It is for protection of those sensitive trees which we keep protected from the insolation directly. You can see if it is in the north side here, this is the north side here. Let's assume north here, this is the north here. So if you have a forest here, you can see how the oblique the sun is coming here. As it comes here, you can see this is the where we are doing seeding felling, secondary felling, final felling. You can see here the microclimate has been changed. more warmth microclimate will be there in this side of the forest, just because of the more light enters in the deep inside the forest here. More light is exposed this side, regeneration will be more extended to this side in the northern side. As in the southern, you will have a cool microclimate here. You can see the seedlings are not been inside the trees here, it is just nearby here. But on the northern side, seedlings are germinate even inside the forest. So in the southern, lowest light level is there. So this is what we can see. You can see this is in equator. Here in the overhead there will be not much effect here, but the effect will be more on the northern hemisphere here for the group system. So what we do, again let's come to that same group where it was advanced growth. First we go here seeding felling, then as seeding felling we achieve here, then seeding in the first ring, and in the second ring we'll shift seeding felling here, we'll do first ring secondary felling, and in the third ring when seeding felling has been successfully done in second and secondary felling done in one, then we'll go for the removal of more trees. In ring 3 we do seeding felling, and then in ring 2 we'll do secondary felling, and ring 1 will do final felling. And similarly we'll keep on enlarging. We can see here in the last ring we are doing here seeding felling, in this ring we are doing here secondary felling, in this bluish color we can see we are doing here the final felling. Though you can see the crop is growing like this, like a pyramid, it is growing like this, because final felling we are doing already, trees is growing nicely. Here seeding felling has been done, here secondary felling has been done, here final felling has been done. Simultaneously secondary felling is been done in the seeding felling in periphery strips around them, and a fresh seedlings rings is around them. So this way the one group was here, one group is here, another group is here, both we are doing, they are merged, they have merged with each other now. In this way the regeneration spreads centrifugally from these natural as well as artificial created nuclei in ever widening rings as a result of seeding, second ring and final felling. As a result of seeding, felling, second ring and final felling, this regeneration felling made there in sequence, ultimately such group coalesce and cover the entire area, so they will merge with each other. You can see here there is advanced growth, isn't it? Then we go for here, if you see seeding felling, secondary felling, seeding felling, secondary felling, final felling. Ultimately you have the seeding felling in the outer side, then secondary felling here, final felling here. Trees have well grown in this center, it will give a pyramid. They have enlarged and centrifugally to merge with each other. You can see this one group has merged with the another group, giving a pyramidal shape. The size of the artificially created gaps and width of the ring made around them, the nuclei of regeneration varies with the species and the light requirement. Now if the light demander species is there, the gaps, the rings will be wider very fast, and if it is a shade bearer, rings will go very slow, they will merge very late in the shade bearer trees. So the canopy has a wavy profile. You can see they have a wavy profile. This is called Gayer's line. This name is called Gayer's line. So you can see at the beginning it looks uneven edge. You can see it looks very uneven edge. This is height is more here, height is very less here. The young crop produced in this group is not so even edge as the crop of the uniform system. In the beginning it looks uneven edge, but as the tree grows, they will start growing and they will cover up this depression here. You can see at the end the depression is very less of this Gayer line. In the beginning it looks fairly uneven edge, but towards the end it looks more or less even edge. Now you can see towards the end this gap is been finished. Those trees are reaching to the same height as the trees are there. So if the regeneration period is long, as Gayer considered regeneration period up to only 40 years, the crop becomes slightly uneven edge. If it is beyond 40 years, it becomes uneven edge. That's why this system has kept to even age, making it a regeneration period less than 40 years. So but this uneven agenate is disappeared towards the end of the rotation. The system is accepted as even age, because you can see in the later stage the height becomes same, this gear line the height becomes same. Towards the end it looks more or less even age. So beyond 40 years regeneration period, it is not been taken under the group system. So what is the advantage of the group system? The young regeneration is protected by the adjoining tree against the frost and insolation.
The regeneration and young crops develops in a natural way, progressively increasing with the overhead light, and continue to be protected by the adjoining trees against frost and insolation.
There is little danger of the seed bearer being uprooted by windstorm, as these are surrounded by unfelled forests.
There is little danger of a seed bearer being uprooted by the windstorm, as these are surrounded by the unfelled forest.
In a group system like this, damage by felling to the regeneration is avoided by regulating felling of trees towards unfelled areas.
Damage to regeneration by felling of the old crop is avoided by regulating of the felling of the trees towards the unfelled forest.
So this is felling, what we will do, this is unfelled area, this is the regeneration, we will fell on the unfelled area, so we can save the advanced growth and the new regenerated crop. What is the disadvantage of this group system? In hilly terrains, survey and location of this group is extremely difficult.
The group of existing advanced growth to be located and surveyed is extremely difficult, especially in the hilly terrains. In hill forest, there is a considerable damage to the regeneration by sliding logs and timbers.
Location of nuclei or regeneration for weeding and cleaning is very difficult, becomes very costly.
As the work gets diffused, the supervision, weeding, cleaning and other tending operation becomes very difficult due to over extensive area.
The system succeeded only when it got individual attention of a single officer for 30 years.
The requirement may need an attention for a single forest officer for 30 years. And in many countries, it is not possible for a single person to keep in one place for a long time.
So one officer has to be deputed 30 years. That so is one of the most difficult thing, which is for the group system. Then only success can be achieved. The group of advanced growth and artificially created gaps could not be mapped in practice because of difficult hilly terrains. Therefore, regeneration could not be properly tended.
In India, first it was tried for Pinus valenciana in Pabar and Cedrus deodara in Chamba, Himachal Pradesh. But due to heavy invasion of grasses, accidental fire and grazing, and overall mapping the advanced regeneration in practice was very difficult. Hence, the regeneration could not be properly tended.
So tending is very difficult here because the advanced growth and the artificial gap could not be mapped in practice because of the difficult hilly terrains and in large extent area. So we have finished the group system under the shelterwood system. So keep watching the next theory and practice of silviculture lecture number 15 with other system under the shelterwood system. Thank you very much.